Okay, so now that I have all my quantities, it'll be easier for me to draw my graphs. So let's start with the, there you go, position time. This can be the simplest of them all. This is the last one we're going to do, okay? So position, it's always a great idea if you include the units so you don't have to write them down. And then this is time in seconds. Then for the velocity, I'm going to need a long horizontal axis because the time frame, right, the 480 seconds, that's a big number. So I have velocity, and that's in meters per second. And then this is time in seconds. And then I'm going to have an acceleration one. In this one, since I have negative acceleration, I do need to continue my graph toward the negative side, okay? There you go. And this is acceleration. The unit is meters per second squared, and this is time in seconds. Let's start with the acceleration one, because that's the easier one. It's constant, right? So for part one, we have a positive acceleration of 0.05. So then I'm going to just say, let's say 0.05. This is not going to be, the scale is going to be off, but it's okay. So this is going to be 0. Whoops. Let me move my graph so I have more room here. There. This is going to be 0. I can do this, guys. I can do this. 0.05. There you go. And then I'm going to use the same color just to keep consistency. And now I need my time, right? So let's say for 80 was here. This is my time for 80. 480 seconds. Okay. So then my second marking for time should correspond to this one. However, I need to add them up, okay? I need to have the total time. So that'll be 480 plus 50.9. That is 530.9. So let's say 531. So now say that this is 531. Okay. So for 480 seconds, I had a constant positive acceleration of 0.05. Then I began to slow down. A real graph will have a slight curve. For us, we're not going to have curves, as I said. Now I need to have, let's say here is negative 0.55. So now my graph will go down to that level. And then it goes for this amount of time. But then we come to complete stop, which means that it has to go back to the 0 level, okay? There you go. And then you won't be able to see it, but my graph continues here, okay, at 0, because it stops. So there we have it. There's our acceleration time graph. So now let's move on to the velocity time graph. Well, that's going to be simple. I'm going to have a positive slope and then a negative slope. So now I need to have my initial velocities here. So let's say this is the 4 meters per second, and let's say here's the 28 meters per second. And then we have the 480 and then the 531. Okay. It is important for us to not begin at the origin because we do have an initial velocity of 4, which is not 0. So now we're going to have a positive slope, right, up to the 480 mark. There you go. As you can see, the velocity went from 4 to 28 for a span of 480 seconds. And then we're going to slow down until we come to complete stop. So from 28, we go to 0. There you go. And this is the 50.9 seconds. There is my graph. Acceleration, deceleration. And then we should continue the graph at the 0 level, showing that it stopped. And now, this one, I'm not going to have the times there. But since I have positive acceleration, let's assume I started at the origin. We don't have that information, but we don't need to know. That's fine. I could include the displacements. It is not necessary because then it gets a little weird. But just I want to show how it would look. So we have this graph like that. Starts flat, gets a slope, right? So we start at 4, and then we go up to 28. And then we're going to slow down. Okay, we're going to slow down. So we continue, and then we get flat. This is a 28, and then it gets to 0. Okay, so there you go. Acceleration, deceleration. And now we have a complete model for this problem.